So if you flip the page to the graphs and descriptive statistics activity, it says you have a data set, and you do not yet have a data set. That's because I'm about to pass them out. Okay, take a minute and kind of explore your data set. Get a little bit familiar with what you're looking at here.
What?
Right.
It's like you don't remember what happened on the Titanic.
Do we have somebody who doesn't know what happened?
No, he goes, I guess it was like, I guess it's a bad day to be a male.
Someone really did like raise it.
It was a bad day to be a man, yes.
It's a great day to be a first class.
First class woman? Or second class traveler.
Compare your sample with somebody else's sample.
Oh, boy.
Oh, that's even better.
There's like 35 people on the Titanic.
You will notice that you do not have the same sample.
How did this happen? That might have been her.
Is that the case?
No, that might have been. I just need to get your name. Oh no, Mrs. Joseph. Because sometimes, like, if you're married, you're referred to as like.
Now, when I'm asking in number 2, what type of data is in each column, I'm asking quantitative versus qualitative. Does everybody know what quantitative and qualitative data are? Quantitative data are numbers, measuring kind of data, and qualitative data are labels, words kind of data. Okay? Label kind of data. Okay? What a great question, Cody. Can anybody answer Cody's question? Cody asked, is class quantitative data? Is passenger class a quantitative data?
I say it's qualitative.
You say it's quantitative, not qualitative. And you say, did you say yes or no?
Not at the same time.
You said it's quantitative, not qualitative? Anybody else say different? You said qualitative. You said qualitative. All right, so who wants to argue their case? Go for it.
So the reason I said qualitative was there was a connotation among like the passengers, and it's not necessarily that the number is assigned, but it's the like
Label.
Yeah, it's the label they have. First class was the richer people, and while it had while there was like a monetary value to your like status, in this case, I don't think that like two doesn't really mean the same thing as like middle class. Like it's more about this like there's a word I'm looking for. Help me out there.
I don't know. I think it labels that person. It's not saying. It's not like an age or something.
It's not necessarily told.
Would you like to argue your case?
Apparently I misunderstood what I was arguing, because I'm saying that it is not a numerical value, it's a label.
Oh, okay. So you're agreeing with them?
Yes.
Okay.
I thought they said something totally different.
Oh, good. Well, then we're all happy. You're right. It is qualitative data. It is a label. And this is risky because when you use numbers to label things, you run the risk of forgetting that it is a label and not a numerical value. And sometimes when you see a column of numbers, you start averaging and finding standard deviations, and you say, oh, well, the standard deviation of the passenger class was, and that doesn't even make any sense. So you have to be a little bit careful when you're talking about data types, make sure that you're treating the data type by what it is instead of what it looks like. Does that make sense? All right, so go ahead and answer the first two questions in your groups.
What? Just this first?
All right, guys, what does random sample mean?
A group of people that are chosen. It's just a random group of people that are chosen for an experiment. It's not even planned out. It's just
There's no preference to
Yeah.
the people that are chosen.
Yeah, everybody in the sample had an equal likely chance of being part of the sample. Everybody in the population had an equal likely chance of being part of the sample. In this case, I have an Excel file that has every passenger in the Titanic listed, and I have an Excel formula that randomly selects passengers out of that file. Okay. By the way, it does not include crew. The crew are not listed in this file, so we are missing their information.
I was looking for crew.
So they're just not listed here. Okay.
I want to really get people on my head.
They're not here. They're not in that file. Okay, so it is important when you're doing statistics to make sure that whatever sample you're working with, if you're trying to talk about taking information from your sample and making conclusions about your population, that your sample be representative of the population. And if you make a random sample, chances are it will be representative, hopefully. But if you have biased that sample in any way, it is really hard to unbias the sample. So it's really important to do your sampling correctly in the first place, because it's really hard to fix it later on if you've done something incorrectly at that early stage. Okay. Okay, so second question, which type of data do we have for the different columns? We already talked about class. What about the survived column?
Quantitative.
Quantitative or qualitative?
Qualitative.
Qualitative. What about the gender column? Qualitative. What about age? Quantitative. So actually, age was the only quantitative value in this data set. Age was.
Will you explain how survived is qualitative?
Yeah.
Survived is qualitative because it's a yes or a no. It's a label. There's no number attached to it.
Oh, I thought just because like this number of people survived, this number of people didn't, that it was quantitative.
Well, when you have qualitative data, you can then be interested in numbers about the qualitative data. So you can be interested in the proportion of people who responded this particular category. So for example, if I am doing a survey of political interests, I can be interested in what number of people are Republican versus Democratic, right? That is a number, but the original question was qualitative, right? Are you voting Republican or Democratic, right? So I can take my qualitative data and get numbers out of it, but the original question was a yes or no question or a Democratic Republican question, right? Does that make sense? Okay. Okay, let's look at that next question. The age column. Some of you may have blank values under the age column, and some of you have fractional values under the age column. What's that about?
You don't know how old they were.
Yeah, we have missing values. Why do we have missing values?
Those are old.
And then I'm writing into the.
Yeah, when people are buying tickets to go on a cruise, they're not necessarily going, I want to go on a cruise and by the way, I'm 14. Like, that's just not part of what you do when you're making a purchase, right? So it's missing because that's just the nature of the deal, right? What about the fractional numbers?
It must have been.
Hmm?
And then you can do like 22 and a half. Maybe I said that. Maybe I wrote that down.
Maybe like a rough estimate, like they knew, like maybe what the general age of them might be, but not exactly.
So maybe do they?
Who has a fractional number? Who has a what do you have?
26.5.
You have a 26.5? What do you have?
60.5.
60.5. What do you have?
0.8333.
0.8333.
What kind of an age is that?
What is that age?
Child.
0.833 is 11 months. 40.5? 26.5. You had a lot of 0.5s. I almost always get infants. This is an interesting class. What do you have?
0.75.
0.75. That's a what, 8 months old. So most of the time they're infants. Infants are reported in months, and so when you convert them to years, you get fractions. I don't know what this is with the adults reporting in half years. That's weird. Maybe they reported 2 different years, and then whoever wrote them down averaged the years or something like that. I don't know. Okay, so at this point, it's time to summarize your data. We want 2 or 3 or more graphs that summarize your data sets. I want you to discuss with your group what kinds of graphs you're going to use to summarize the data set that you have in front of you. You've been working with graphs your entire school career. You've got some under your belt. Take them out, dust them off, show me what you've got. And also don't forget about numerical summaries. You know, do you use some proportions, some means, whatever, do some summaries. But what you're doing in number 4 is you are planning. You are talking about you're talking with your group about what your plan is. You're not actually doing the graphs, okay? So take 2 or 3 minutes to do that plan, and then we'll report out, okay?
And
Post all this.
well, like on modern dot graphs, I'm like, here you can choose which one's the color. So it'd be easy. You just have a legend. But you can also do like,
Now at this point, when I usually teach this lesson, I usually send you home and I say, now go make these graphs. And then when we come back, we'll share them out. But we've got the camera here and I want to share them out before the camera's gone. One graph. Or are you showing something like the survival rate for males and the survival rate for females?
We actually do like one of these on the Y-line, which is like survival rate for males versus females. Just so that we do the survival rate, or like anything.
It doesn't matter. Anything you want to show.
So like
Survival rate on 6.
You've had a chance to spend all this time on those graphs, and I'd love to see an example. Can I have a volunteer? Male and female, and this is survived. So this is, what, 3 men survived and
that's 8, sorry.
8 men survived?
No, 8 female.
8 females survived.
Might be a 7. It's
supposed to be made.
Oh, okay, so eight women survived and 3 men survived. So this is showing the differences between men and women's survival rates. That's interesting. And it's interesting because it's combining the 2 different data types, right? And over here we have
the percentage of the class that survived. Like first class, the survivors, 63% of the survivors were first class.
Oh, okay, so this is the percentage of the survivors that were of the different classes. Okay, so 63% of the survivors were first class and 18.5% were second class, etc. Which is impressive because not that many of the people on board were first class. So that says a lot for the survival rate of the first class. Okay, thank you. Do I have another volunteer? Okay, we have the survival rate for the men. 86% did not survive. Not very good for the men that day. Yeah, that's pretty brutal, isn't it? This is survival versus gender again. So we have the same kind of dismal relationship between gender and survival. The men had much lower survival rates. It's interesting that the 2 different data sets had similar survival numbers, 3 and looks like 8. Was that an 8 or a 9?
It was 2 and 8.
2 and 8. So that's interesting. That brings up a point that I would like to make, which is that even though we make these random samples and we get variation, the general trends stay the same, right? The proportions get slightly altered over time as we make these random samples, but they stay fairly consistent. That's okay. This is 31.5, this is 38.9 for second class, and this is 29.6 for third class. These are the class survival rates, which is kind of different. I was just saying that the trends stayed the same, but that's pretty dramatically different than the other group had.
Thank you. I'm going to have to go to the museum now.
So we have, over here we have survivors, and these are the ones that died. And it's first class, second class, third class, and these, this is still first class, and this is first class, second class, and third class.
What color represents it? So like the split in the middle, where the orange and the pink, like the orange is the guys and the pink is the
Oh, wow, you got 3 different data types in the same graph. I'm impressed. Very nice. I'm impressed. So the colors represent the men versus the women. So it's interesting that for the survivors, the second and the third class survivors were all female. There were no male second and third class survivors. I would love to see this graph for the whole data set. You really came up with something. This is good work. I love this.
Thanks.
Yeah. They're so happy. And look, they put up here that 31% survived and 66% died. So you know what we need to do now is we need to scale the sizes of them and make this one bit smaller and this one bigger. Okay, we need to talk about numerical summaries of data because the title of this activity is Graphs and Descriptive Statistics, right? And you've already given me descriptive statistics, right? You told me what percent of people survived and what percent of people died. You told me what percent of people were male and what percent of people were female. Those are descriptive statistics. When you have qualitative data and you tell me percentages, you are describing your data with descriptive statistics. But when you have quantitative data, you don't use percentages to describe your data. What do you use? Numbers. You use means, medians, modes. You've heard of these numbers before, right? What's a mean? Average. What's a median? Middle. What's a mode? So I don't need to talk about those, right? Okay. Do you know how to get those on your calculator? Do you have your calculator with you?
Yes.
Okay, take your calculator out. Arrow buttons. Press the stat key. Up at the top of the menus that you get, there is Edit, Calc, and Tests. Highlight Edit, and you see L1, L2, L3, whatever. Get some data into one of those. Just randomly type some numbers in there so you've got some numbers, okay? You might even enter some of your age data if you wanted. Okay. Once you've got some data in there, then go back to the Stat button and now go to Calc. Hit one var stats, and then it's going to blink at you. Depending on the type of calculator you have, it's either got a menu blinking at you or it's just blinking at you with a command line. It's waiting for you to tell it where the data is. So if you put the data in list L1, you're going to go second one for L1 and then hit enter. And then it's going to tell you all the wonderful stuff that you need to know about that data. X bar, it's going to tell you a bunch of stuff you don't need to know. It's going to tell you SX, it's going to tell you sigma X, it's going to tell you N, it's going to tell you the minimum Q1, which we'll discuss later, the median, Q3, the maximum, all sorts of stuff that you will need to know later. Okay, so online, in the same place where the helper, hinderer homework is, there is a graphs and descriptive statistics homework. You might as well go ahead and do that one at the same time as you do the hinderer homework. It's going to walk you through doing graphs on the TI-83 calculator. Okay? Guys, I'd just like to review today. We talked about statistical significance, about how p-values are the probability of getting data like you saw or more extreme if the null hypothesis is true, and small p-values mean that your data is statistically significant. We talked about graphs and descriptive statistics and how you actually already know all that stuff and you just needed to be reminded of it. And we did a very, very quick refresher on the calculator. Okay? And I will see you on Tuesday. Have a good weekend.